absolute value functions as piecewise functions. After this lesson, you will be able to write an absolute value function as a piecewise function. So first, let's remind ourselves what a piecewise function is. A piecewise function is a function with two or more different sections of the graph. So we remember this is what piecewise function looks like, where we follow this equation when x is less than 3, and we follow this equation when x is greater than or equal to 3. Circle the two different sections of this absolute value function. Hint, locate where the function changes directions. So take a look at the graph. Circle what you think would be the two different sections. So hopefully you saw that at the vertex where it splits, on the left is one section, and on the right is the other section. The point where they crossed is that axis of symmetry, which is why we have this x value of 3. This red line is going to follow this top equation, and this purple line is going to follow this bottom equation. So that's what we're going to be working on, is writing our absolute values as piecewise by focusing on the left half and the right half of the graph. So let's start with an example. First, I want you to identify the value that is going to be used for the interval, aka where does the graph change? Hopefully you saw that the vertex was at the point 0, -5, which meant that it was going to be crossing at x is 0 for both of them, and that's where the change was. So I'm following the left side, I hit 0, I switch to following the right side. Now, to be able to find the rest of my equation, I need to be able to find the equation of a linear line. If we remember, it's going to be following mx plus b. The first thing we can find is the b, which is where it crosses the y-axis. In this case, it's also the vertex at -5. So next we need to find our slope. Well, our slope is how it changes. So if I have to go down, I know that down is a negative direction. So I'm going down 5. If I have to go over to the right, that's +5. So my slope is actually -5, my change in y, over 5, my change in x, which is going to give me -1. So my m is -1, and then we have our x. So my top equation is going to be -x, and that makes sense since we are going down the mountain, -5. Do your best to write the equation for the right side of the graph. Remember, you're finding your slope and your y-intercept. So my slope is my y-intercept again is going to be at -5 because we crossed the y-axis at -5. Then looking at my slope, I know I'm going up the mountain, so I'm going to be positive. I go up 5 over 5. 5 up divided by 5 to the right equals a +1. So I'm just going to write x. If you wrote 1x, that's okay, but just remember the 1 disappears, and we end up with x minus 5 for the second half of our graph. And there is our final answer, writing this absolute value as a piecewise function. We're going to go ahead and try example 2. First thing I want you to identify is the axis of symmetry to know what we're using for our interval. Our axis of symmetry is moving down the vertex at 2. 2 is where it changes. The x value of my vertex is at 2, and then we went up 4. So again, we're only caring about the x value to get that 2. Now that I know where it switches, I'm going to focus first on the left half of my graph. It's a line, so I know it's going to be a linear equation, so it's going to follow the form mx plus b. Do your best. Please write the equation for the left side of the graph. My y-intercept crosses right here at 6, +6. My slope, if I'm moving between these 2 points, I have to go down, which is a negative direction, and I have to go right, which is positive. So my slope is negative 2 divided by 2, which is a negative 1. So I'm going to get negative x. So over here I have negative x plus 6 as what happens when x is less than 2. So when we're to the left of the vertex, where I have a negative 1 slope, and we cross the y-intercept at 6. Try your best to find the equation for the right side. I'll give you a hint. You have to extend it to find the y-intercept. So let's go ahead and extend it. I notice this is going up 1 over 1, up 1 over 1, up 1 over 1. So I know I'm going to have a positive 1 slope. If I continue that slope, I cross the y-axis. So again, imagine that the line continued down. We're crossing the y-axis here at 2. So we get plus 2. And there's my final answer of my absolute value as a piecewise function. Try your best to find the answer for example 3. Go ahead and fill out the entire piecewise function and check your work. So the first thing I want to do is identify my axis of symmetry, because that tells me where I split my piecewise. In this case, it is at the value x is 4. The next thing I'm going to do is find my left side, where it's less than 4. I know that here it's going to cross at positive 3. My slope is down to the right. So down 1, right 1. Negative 1 divided by 1 gives me a negative x. Notice when you look at all of the examples, the left side, if the graph is pointing upwards, is always going to have that negative x value. Then I'm going to go ahead and do it for my right side. My slope is pretty easy, up 1 over 1. So I know I'm going to have a positive x for my slope. I have to continue that slope till I find where it crosses the y-axis. So if I was to continue that line, I would cross the y-axis at negative 5. And there's my piecewise function for example 3. Go ahead and try your best on example 4. Keep in mind, this function is pointing downwards, which means your slopes are going to be opposite of what you usually see. Check your work. Be awesome. So first I need my axis of symmetry to see where I split my graph. This is going to happen at negative 1. My left side of the graph is going to have an upward, so a positive slope, up 1 over 1, up 1 over 1. So I know I'm going to have a positive 1 slope. Then I have to continue it till it crosses right here at positive 8. To find the right side, I know that it's going downwards, so I should have a negative slope. It's going down 1, right 1, down 1, right 1, so I know I have a negative 1 slope. And it crosses right here at 1, 2, 3, 4, 5, 6, at positive 6. And there is our piecewise function for this absolute value graph. Notice again, on all the other examples, it was negative x on the top and x on the bottom. Negative x on the top, x on the bottom, when the graph is pointing upwards. But when we have a graph that is pointing downwards, we notice that the slopes flip. But as long as you use your slope mountain, you can always check it. If it is going up the mountain, we are positive. If it is going down the mountain, we are negative. So that makes sense that we have a positive slope on the left side and a negative slope on the right side. Great job getting through these notes. Do your best on the practice for the lesson, and I hope you always remember how incredibly awesome you are.